This is the first of 3 videos that we're going to use to teach about stoichiometry. And stoichiometry is a combination of the past 2 major concepts that we've learned about in class, the mole and balancing of chemical equations. See, stoichiometry is the study of the quantitative aspects of chemical reactions. That is to say, the part of chemical reactions that involves numbers, predictability, that type of thing. So put another way, it's the relationship, the quantitative relationship between the amount of reactants used and the products formed by a chemical reaction. This again is based on the law of conservation of mass and energy. The key important point to remember about this is that we're always going to start with a balanced chemical equation. Stoichiometry problems are impossible without a balanced chemical equation. It's also important to note that during this kind of problem, we are going to be changing from one substance to a different substance. Therefore, the labeling of your units is going to be extremely important. So here's an example problem, the very simplest type of problem. It's called a mole-to-mole problem. It's called a mole-to-mole problem because the unit that we're starting with is 3.5 moles of propane. And we're going to moles of a different substance, carbon dioxide in this place. So because we're going to be going from one substance to a different substance, we're going to be using something called a mole ratio. A mole ratio is the ratio between the number of moles of any 2 substances in a balanced chemical equation. And this is the tool that we're going to use to convert from one substance to a different substance. So let's see that problem again on this next page. How many moles of carbon dioxide form from the combustion of 3.5 moles of propane? We have everything we need to solve this problem. First, we have to start out with a balanced chemical equation. So we have to write that equation. C3H8 is involved in a combustion reaction. Well, combustion means we have to have oxygen. And we're going to form the same 2 products always. Carbon dioxide and water. When we balance this equation, we find that we need 5 oxygens here, 3 carbon dioxides, and 4 water molecules. Now that we have the balanced chemical equation, we can start to set up our stoichiometry problem. At this point, we could also analyze our mole ratios. So what this equation says is that 1 mole of propane will react with 5 moles of oxygen to form 3 moles of carbon dioxide and 4 moles of water. So you could say that a lot of different ways. You could also say that 1 mole of propane will form 3 moles of carbon dioxide. 1 mole of propane will also form 4 moles of water. Each one of these scenarios where we mix and match is a mole ratio. So back to the problem at hand. Just like what we've been doing all along, you're going to start with a substance that you're given. 3.5 moles of propane, C3H8. And here's where our dimensional analysis is going to come in. We're going to place that over 1. We're going to multiply it by the mole ratio that eliminates the substance that we start with and gives us the substance that we're trying to end with. So if I want to get rid of the moles of C3H8, it has to go down here. I want to get moles of carbon dioxide, so I put that on the top. And here's where the balanced chemical reaction comes into place. Anytime we have mole and mole in the same fraction, right here, the numbers that go with that come from the balanced chemical equation. In the balanced chemical equation, 3 goes with carbon dioxide and 1 goes with propane. In doing this here, we cancel the unit that's the same on the top as on the bottom, and we get our new unit, moles of carbon dioxide. 3.5 times 3 equals 10.5 moles of carbon dioxide. And this right here is our first stoichiometry problem, a simple mole-to-mole conversion.